So I will present you a bit more into the detail what I presented you very rapidly yesterday. So our setup UV film for live cell imaging of fully functional nucleic acid is based on this guanosine analog, so TAG and TZG, which as you can see are super close to this one, and to the real guanine. And it has been shown that they can substitute almost perfectly, almost in this case, and really perfectly in this case. And the DNA and RNA which have been produced so far are fully functional. And on the top of that, they are quite bright, even when included in the nucleic acids. Depends a little bit on the sequence, nevertheless. They are environmentally sensitive, so they respond to change in the environment by a shift in the spectrum and a change in the quantum yield. And on the main interesting property is the fluorescence lifetime, which is between 5 and 30 nanoseconds, which is super easy to discriminate from the background. And so they are really unique for monitoring intracellular DNA and RNA without disrupting their activities. So just to show that it is feasible, this is an experiment that has been done in Germany because we have not so far the laser which is suited for that. And this is the background from the cell, and you see that the lifetime are pretty short. And when we just inject, we just add TZG or TAG to the cell, you see that the lifetime be very easy to discriminate from this one. It can be also seen very easily on the shape of the decay curve. So FLIM is a simple technique that can be used to see the TAG. This was just TAG, yeah? Not TAG inside DNA. It's an easy tool to discriminate TAG from the background. So our idea is to make a quantitative, versatile microscope for monitoring intracellular nucleic acids. So we will perform this wide field FLIM mode, but we would like also to add the possibility to have the confocal on the same instrument, so able to shift from one to the other. So we hope to be able to fingerprint DNA, RNA environment, monitor rare events, and also protein nucleic acid interaction, because we will have a wide field mode with FLIM camera, and we will have two lasers, one an UV laser and one which is a white laser, super continuum one. We hope to have also flexibility for high accuracy of 3D locations. This is with the confocal mode, with a hybrid PMT. And we hope to be able to characterize DNA and RNA dynamics, because it's not very difficult to add up fluorescence correlation spectroscopy variants on the same setup. So for the moment, we have not started because we have to buy all these items together. And for the moment, you know that the market is quite difficult. We have to fill a lot of forms, especially when it is exceeding 90 kilo euros. So it will take a bit of time because of that. Thank you.